All right, what we're going to do here is, if you took Algebra 2, this will be review. If you didn't get to too much of the trig in Algebra 2, then this is going to be new for you, but you do need to be aware of these two special right triangles and how they fit into that unit circle that we built yesterday in class. Okay, so these are the two special right triangles, and they have two names. This first one, you could call it a pi over 6, pi over 3, pi over 2 triangle, right? Because those are the angles. This last one here is a pi over 2 radian angle. And obviously the other way is to convert those into degrees and call this a 30, 60, 90 triangle. And that's the way that you'll probably hear it referred to more often, but the reason I'm going to write it out in radians also is because we're using radians more often than degrees at this point. The other triangle here, it's implied because of these markings in the corner that these angles are equal to one another. These are congruent. And then this is, again, a pi over 2, or a 90-degree angle. So if this is 90 degrees and the other 90 degrees of this triangle are split in half, then these are each 45. Okay, so this can be either called your pi over 4, pi over 4, pi over 2 triangle, or you could call it a 45, 45, 90. These two triangles are pretty important because their side lengths are proportions that we're going to want to remember. So what we're going to do here is we're going to figure out what those side lengths are going to be. Okay? And in any one of these cases, what we usually start with these triangles is we start by just saying, let's say that we assume that these sides have a length of 1. What does that mean for the rest of our sides? Okay, so what we'll do here is we'll say that I know the angle, I know this pi over 3 angle here, and I know the adjacent side. So let's try to find the opposite side, right? And I have a function that incorporates the opposite and adjacent sides of a triangle, and that is tangent. So tangent of pi over 3 is equal to your opposite side over your adjacent side. Okay, so then the question really just becomes, what is tangent of pi over 3? And just make sure that you're in radians on your calculator. But what you're going to get is you're going to get a decimal that is actually equivalent to the square root of 3. So this side has a length of the square root of 3, if that bottom leg has a length of 1. It's longer, right? So this is a bigger number than 1, okay? But it's not going to be the longest side in this triangle. This is going to be the longest side on the triangle. And there's a couple ways you could get to this side. Now that we know two sides, let's just use the Pythagorean theorem and say that we have a squared plus b squared equals c squared to find that hypotenuse. That leaves us with 1 plus 3 equals x squared, 4 equals x squared, 2 equals x. So this side has a length of 2. All right, so that 30, 60, 90 triangle, or pi over 6, pi over 3, pi over 2 triangle, has these side lengths. And we're going to want to remember those because we're going to make that triangle bigger and smaller, but the proportions aren't going to change. So we're going to use those proportions to help us figure out the side lengths of similar triangles. Over here with the 45, 45, 90 triangle, there's an automatic calculation you can make here. If you remember your rules from geometry, these angles are congruent. So if these angles are congruent, then the sides opposite them must also be congruent. So this side also has to have a length of 1. And then we just have to figure out what the hypotenuse is, and that's another Pythagorean theorem situation. So we have a 1 squared plus 1 squared equals the hypotenuse squared. 2 equals x squared. So x equals the square root of 2. All right, so that side now has a length of the square root of 2. And so these two special right triangles are triangles you should commit to memory. You should be well aware of these lengths. Because if I were to say that there's a new triangle, and I'll just draw it here like this, and you can tell now that it's a 45, 45, 90 triangle because of the angles, but I say that this side has a length of 1/2, you can adjust the other sides to fit that, right? If this side used to be a 1 and it's now a 1/2, then it must have been divided by 2. So I have to divide that side by 2 and divide that side by 2. All right, so then my other sides are going to be 1/2 and radical 2 over 2. And so now I have those sides. And all we've done is we've taken that triangle and we've just shrunk it. And I could do the same thing in blowing it up. Maybe I give you a new triangle that looks like this. And I'm just going to make it a little trickier here and say that this is your pi over 6 angle. And so the thing to keep in mind is that this angle corresponds to that angle in the original triangle. So this whole thing has kind of been flipped on its back. But the thing that I'm going to change is I'm going to say that this bottom side here has a length of 3. Well, if you correspond that side to a side in the original triangle, that's this side. What would you have to multiply or divide that by to get 3? Well, radical 3 times what gives me 3? That would be radical 3, right? Because if you square it, then you just end up with 3. So I just have to multiply every other side by radical 3. 2 radical 3, and 1 times radical 3, and so all the sides change. All right? So that's how you see these transformations start to take shape. And so what we're going to do is we're going to take these special right triangles and we're going to move them into the unit circle. All right, so hopefully what we're going to recognize here is that what we did in class when we built the unit circle and what we're doing here with these special right triangles are two things that are very much connected. So let's start by taking this pi over 3, pi over 6, this right triangle over here, and adjusting it so that it fits inside of this unit circle. So I'm going to take this angle, this pi over 6 angle, I'm going to spin this triangle around and put that angle here. And what that's going to look like when I draw this triangle in is this angle here is my pi over 6 degree angle, that angle is my pi over 3 degree angle, and then this is my right angle. So we just took that triangle and laid it right there inside of the unit circle. And what happened when I did that, if this is my pi over 6, this is my pi over 3, and then my 90 degree angle is there. What happened when I did that is I moved it into the unit circle. And one thing we know about the unit circle is that its radius is 1. And that hypotenuse now represents the length of the radius. So the radius has to be a 1 now, which means this 2 just shrunk to become a 1. And the only way, using multiplication or division, that 2 can become a 1 is if you divide it by 2. So this must be the thing that happened to all of those sides if I was trying to reposition this triangle to fit inside the unit circle. So if I had to divide that side by 2, then I must have had to divide this side also by 2, and this other side by 2 as well. And that's how we figured out in class that 0.866 with all those decimals that go on forever and ever actually equals the square root of 3 over 2, because this point here then must have the coordinates radical 3 over 2, 1/2, or 0.5. So what we've done is we've just taken that special right triangle and we've placed it inside of the unit circle. And all I'm going to do now is just draw a different special right triangle. All right, I'll draw it in blue so that it doesn't look so confusing. And this is the same triangle, but it's just positioned a little bit differently. So this triangle is also a pi over 6, pi over 3, pi over 2 triangle. But this is my pi over 3 degree angle, and this is my pi over 6 degree angle. So in this case, I'm still taking this hypotenuse and shrinking it down to turn it into a 1, which makes the other sides, the 1 divide by 2, and the radical 3 also divide by 2, giving us the point 1/2 radical 3 over 2, We've also got this third triangle. At the risk of making a mess here, I'm just going to try to draw that one in. This one, okay, this is at a 45-degree angle or a pi over 4 radian angle, making this also a pi over 4 radian angle. So that's actually just this triangle here, shrunk down to fit into this space. This hypotenuse, which used to be a radical 2, is now a 1. So how does a radical 2 become a 1? Well, it only can become a 1 if you divide it by itself. So what had to happen then is these sides had to have been divided by radical 2 as well. So what's going to happen if I divide 1 by radical 2? Well, one thing we don't like to do is we don't want to leave square roots in denominators. So what I'm going to do here is rationalize this thing by multiplying it by a version of 1. Radical 2 over radical 2 is just 1, right? But what that's going to do is it's going to make this fraction look a little different, because now I have radical 2 times radical 2 in the denominator. So what I end up with then is sides of length radical 2 over 2 on both sides. And that creates this point. So if you were wondering in class when we used the calculators, how did we know that 0.707 ended up equaling radical 2 over 2? Well, it's because of this. It's because of these special right triangles. And what we're going to do is use these special right triangles occasionally to evaluate these functions pretty quickly. And the big takeaway from the lesson on the unit circle was that we know now that cosine of any angle is equal to the x-coordinate at that angle on the unit circle, and sine of any angle is equal to the y-coordinate on the unit circle at that angle. And so this is something we're going to build on in the upcoming lesson. All right? I'll see you guys tomorrow.